Okay, guys, this is a really important topic on polyatomic ions. So far, all of the ions we have encountered have been monoatomic, which means that they contain a single atom. So we have seen Na+, Mg2+, Cl-, O2-, and others. But a number of very important ions are polyatomic. And what I mean by that is that they contain more than one atom linked by covalent bonds with an overall charge on the entire structure. So we have seen that something linked, when you have atoms linked by covalent bonds, that's normally what we call a molecule. But a molecule that has an overall charge, anything with a charge on it has to be an ion, and the term we use for that is polyatomic ions. Okay, so the first example that I want to give you is what we call the acetate ion. So it has the molecular formula C2H3O2-. It contains 7 atoms, 2 carbons, 3 hydrogens, and 2 oxygens. Now, I always like to think about covalent compounds in terms of their molecular structure. Many general chemistry courses don't pay that much attention to structure, but it helps me to think about it if I can kind of see at least a 2-dimensional picture of it. Because all of these polyatomic ions are things that you're going to have to memorize. So you can see that this structure of this, you have a carbon doubly bonded to one oxygen, singly bonded to another oxygen. That same carbon is also bonded to a carbon. That second carbon that doesn't form any bonds to oxygen has a bond to 3 hydrogens. Okay, so all of these bonds that you see in the structure, the carbon-carbon, carbon-hydrogen, carbon-oxygen bonds, they're all covalent bonds. And one of the things that I'm going to say in this lesson that I will say again and again and again when we start talking about reactions in Unit 2 is that these will never be broken. You never break apart a polyatomic ion. Okay, so then an example of an ionic compound containing the acetate ion would be sodium acetate, which has the formula NaC2H3O2. Okay, so remember in the formula for ionic compounds, we typically write the metal first and the nonmetal second. The nonmetal now, instead of just being Cl, is C2H3O2. And then you can see the structure of sodium acetate here. It's just the acetate ion with a sodium in the vicinity. The sodium plus is going to be in the vicinity of the oxygen with the negative charge on it because of electrostatic attraction. Okay, the other example I want to introduce to you right off the bat is the ammonium cation. So of all of the essential polyatomic ions that you absolutely must memorize, this is the only one that's a cation. The other 7 are all anions. And the ammonium cation has the formula NH4+. So with a nitrogen and 4 hydrogens, it contains 5 atoms. And its structure is this. The nitrogen is simply covalently bonded to the 4 hydrogens, and there is a positive charge on the central nitrogen. Incidentally, later in the semester, there's going to be a unit on covalent bonding, and you're going to look in much greater detail as to why certain atoms have charges in these polyatomic ions. Okay, so an example of an ionic compound containing the ammonium ion would be ammonium chloride, which has the formula NH4Cl. And as you can see, its structure is just the NH4+ and also has a Cl next to it. Okay, so there is a table of polyatomic ions in every textbook, and yours is no exception, and that table will be up on the last slide of this unit. But before I get to that entire table, which has what I consider to be a daunting number of polyatomic ions, I would like to introduce you to what I consider to be the 8 essential polyatomic ions. Okay, so you must memorize the name, formula, and charge of the following 8 polyatomic ions. They will be on the essential outcomes quest. And if you don't memorize these polyatomic ions, you will not pass that quest. And of course, not passing an essential outcome quest means that you will fail the class. Okay, I'm not doing this to be mean. It's that these are used so much in chemistry that you absolutely have to know in your back pocket what their charges, what their formulas are for these 8. So the first one is hydroxide, which is OH minus. I have not drawn out a careful structure of hydroxide because it only has 2 atoms. Oxygen and hydrogen are bonded by a covalent bond. The next one is bicarbonate. So it has the formula HCO3 minus, and you can see it also has a carbon forming bonds to 4 bonds to 3 oxygens, including a double bond. And then you have carbonate, which is CO3 2 minus. Don't get bicarbonate and carbonate confused. A lot of people do. The bicarbonate has a bi prefix, but it only has 1 minus charge. It is the full-blown carbonate that actually has 2 minus charges. Acetate I already introduced you to on the last slide. Another one that has a structure very similar to carbonate, except has a nitrogen as its central atom instead of a carbon, is nitrate, NO3 minus. It only has a net 1 minus charge. Next one is sulfate, so SO4 2 minus. Sulfur is the central atom bound to 4 oxygens and 2 of them are double bonds. Phosphate, PO4 3 minus. Okay, so you see that there are 3 oxygens that have a negative charge, and phosphorus is the central atom. And then finally, ammonium you also met on the last slide. Okay, so those are the 8 essential polyatomic ions. I don't care how you do this, make flashcards. You don't have to memorize the structures. You just have to memorize their name, formula, and charge. But if the structures help you, and in a class this size, there will be somebody for whom the structures help you. That's why I have included them. Okay, so then the rest of the polyatomic ions on this list will only be tested as a general outcome, not as an essential outcome. So again, we've got our essentials that are all on this list, but other ones that we encounter are cyanide, and you've probably heard of some of these in the course of your general scientific knowledge. Thiocyanate, okay, bicarbonate is there. It's also called hydrogen carbonate, but that is just not used very much. I would like you to know the name bicarbonate. Then you also have bisulfite, bisulfate, nitrite, permanganate, hypochlorite, chlorite, chlorate, perchlorate, peroxide, sulfite, thiosulfate, oxalate, chromate, dichromate, phosphite, and mercury 1 as the other polyatomic ions that are on the table in your textbook. Okay, so the more of these you learn, the better a chemist you will be, but they're not quite as essential as the 8 essentials. So just a few of these, again, I'm using my bias here and putting structures up there on the screen. So chlorite is ClO2, chlorate is ClO3, and perchlorate is ClO4. And then oxalate is actually one that you're going to use in lab because you're going to make an iron oxalate complex in lab later this semester. And that is C2O4 2 minus. You see how that is put together. So anyway, in terms of trying to systematize some of the rest of this, if what I'm going to say now helps you, use it. If it doesn't help you, don't use it. But all of the polyatomic ions with more than 1 oxygen are ending in ite or ate. And the ate always has 1 more oxygen than the ite does. Okay, so you see chlorate has 3 oxygens, chlorite has 2 oxygens. Nitrate has 3 oxygens, nitrite has 2 oxygens. Now don't confuse these endings with the ide endings that we learned previously for the simple anions. These ites and ates are for polyatomics that contain oxygens. And then finally, the per prefix means even 1 more oxygen. Okay, so you notice that chlorate has 3 oxygens and perchlorate has 4 oxygens. Per is kind of the prefix that means extra or the most. And then hypo prefix means 1 less oxygen. So hypochlorite has one less oxygen than chlorite does. It's just OCl. And hypo usually means less or fewer. So like we talk about things being hypoallergenic if they reduce the allergic response when people are exposed to them. Okay, and then hypochlorite is an ion that you actually encounter quite a bit because sodium hypochlorite is the active ingredient in household bleach. Okay, so in the course of the last 4 lessons, you have learned about ions, you've learned about formulas, you've learned about basic nomenclature, and now we've added polyatomic ions. Okay, so now we're going to change gears in our next lesson and talk a little bit about solutions.